In this lecture, we'll discuss logarithmic inequalities. Now, basically, logarithmic inequalities are simple. There are just two steps that we need to follow. And the step number one is we must always take care of its domain. And for any log, the conditions for domain are x should be greater than 0, base should be greater than 0, and base is unequal to 1. So that's my first step. And the second thing that I need to take care of is I need to identify whether the base lies between 0 and 1 or base is greater than 1. When the base lies between 0 and 1, log x, it is a decreasing function. And when base is greater than 1, then log x is an increasing function. Now what will happen is, if the base lies between 0 and 1, and if I take anti-log, then sign of the inequality, it reverses. Now because it is a decreasing function, so if I take anti-log, the sign of inequality will reverse. And if it is an increasing function, and if I take anti-log, sign, it will remain the same. So for any logarithmic inequalities, there are only two steps. First, you need to take care of its domain. And secondly, when you're going to take anti-log, you need to decide whether the base is less than 1 or the base is greater than 1. So when the base is greater than 1, if you take anti-log, sign will not change. And if the base lies between 0 and 1, and if we are going to take anti-log, then the sign reverses. So there are two kinds of inequality problems in logarithms. One with a constant base and second with a variable base. So we'll start with the problems with constant base. Say for example, the question is 2 minus log x square plus 3x to the base 2 is greater than or equal to 0. So first thing what I'll do is I'll find its domain. Now the condition of domain is a is already greater than 0, it is not equal to 1. So the only condition I'll have here is x square plus 3x should be greater than 0, which is x plus 3 is greater than 0. So this is minus 3, 0, plus, minus or plus. So either the value of x is less than minus 3 or the value of x is greater than 0. So that is the condition of domain. Now I can write this as, so I'll take this log on the right hand side, I can write it as log x square plus 3x is less than or equal to 2. Now we look at the base of this log. Now base is 2, which is greater than 1. So when the base is greater than 1, and if I'll take anti-log, sign doesn't change. So I'll write this as x square plus 3x is less than or equal to 2 square. So x square plus 3x minus 4 is less than or equal to 0. So which is x plus 4, x minus 1 is less than or equal to 0. So this is minus 4 and 1. So plus, minus and plus. I need minus less than 0. Now I need to take the intersection of these two conditions. So I'll draw a number line. I'll write both the solutions. So the interval which is common to both is x belongs to, now included minus 4 to not included 3, union not included 0 to included 1. So that is the answer to this question. Now suppose the question is log x plus 1 to the base 1 by 2 is greater than log 2 minus x to the base 2. Now first I'll write domain. So for this one, it should be x plus 1 should be greater than 0. And for this one, I'll write 2 minus x should be greater than 0. So x is greater than minus 1 and x is less than 2. Now I'll try and solve this inequality. So what I'll do is, I'll write this 1 by 2 as log 2 to the power minus 1 So 2 to the power minus 1. Now I'll use property of exponent of base. So I'll take this minus 1 out. So I'll write 1 upon minus 1 log x plus 1 is greater than log 2 minus x. Now I can take it to the power of x plus 1. So I'll write log x plus 1 to the power minus 1 is greater than log 2 minus x. Now it is log 2 and log 2 here. Now because the base is greater than 1, so if I take antilog, sign doesn't change. So I'll write 1 upon x plus 1 is greater than 2 minus x. Now I'll take everything on the left hand side. So I'll write 1 upon x plus 1 and then plus x minus 2 is greater than 0. So if I'll take reciprocal, so if I'll rationalize it, I'll get x plus 1 and this is 1 plus and this is x minus 2x plus 1 and it is greater than 0. So I'll write x square minus x minus 1 upon x plus 1 and this is greater than 0. So the roots are 1 plus minus under root 5 by 2 and x is equal to minus 1. So I'll put them on a number line. So it will be minus 1 and then 1 minus under root 5 by 2, 1 plus under root 5 by 2. So rightmost is plus, minus, plus and minus. I need greater than 0 which is plus. Now I need to take the intersection of first condition and the second condition. Now the first condition says x is greater than minus 1 and x is less than 2. And the second condition says x lies between minus 1 and 1 minus under root 5 by 2 and then it is greater than 1 plus under root 5 by 2. So the interval which is common to both is x belongs to, so from minus 1 to 1 minus under root 5 by 2 union 1 plus under root 5 by 2 to 2. So we'll take another question and the question is log base is 1 by 3 log again base is 4 x square minus 5 and it should be greater than 0. Now what I see here is I see base as 1 by 3 which is less than 1. So if I take anti-log, then I know sign of inequality will reverse. So I'll get log x square minus 5 to the base 4 and it should be less than 1 by 3 to the power 0. Now I'll also need to take care of its domain and the domain condition is any value of x it should be greater than 0. So that means this number should be greater than 0. So now I'll take anti-log again. So if I'll take anti-log, now here the base is greater than 1. So if I'll take anti-log, sign doesn't change. Sign won't change, right? So I'll write 4 to the power 0. X square minus 5 is less than 4 to the power 1. So this is 1 is less than x square minus 5 is less than 4. So now I'll solve them separately. So I'll write this as 1 minus x square minus 5 and x square minus 5 is less than 4. So from here I'll write x square is greater than 6 or mod x is greater than under root 6 and from here I'll write x square is less than 9. If I take under root I'll get mod x is less than 3. Now when mod x is greater than a then either x is less than minus a or x is greater than plus a and when mod x is less than a it lies between minus a and plus a. So now I'll take the intersection of these two conditions. So I'll write this as minus under root 6 plus under root 6. So either x is less than minus root 6 or greater than plus root 6 or the value of x lies between minus 3 and plus 3. Now the interval which is common is x belongs to, so from minus 3 to minus under root 6 union under root 6 to 3. Now there'll be some questions where we'll have logarithmic inequalities with a variable base. Now what do we do in such problems? So what I'll do is I'll take up an example. Say for example, so the question is log 4x plus 5 upon 6 minus 5x to the base x, and it should be less than minus 1. So the first thing I'll do is I'll find its domain. And the condition for domain is this x should be greater than 0. So 4x plus 5, 6 minus 5x should be greater than 0. So I'll take up a number line. So this is minus 5 by 4, 6 by 5. So minus, plus and minus, I need greater than 0, which is plus. So the condition I'll get is the value of x should lie between minus 5 by 4 and 6 by 5. Now here I'll not consider conditions of base because I'll do it in the second step. Now in the second step, I'll take two separate cases. Case 1, when the base lies between 0 and 1, and case 2, when base is greater than 1. Now when base lies between 0 and 1, I'll write the question as log Now because base lies between 0 and 1, log is a decreasing function. So if I take anti-log, sign will reverse. So I'll write this as 4x plus 5, 6 minus 5x. It is greater than x to the power minus 1. So which is 4x plus 5, 6 minus 5x is greater than 1 upon x. So I'll take this 1 upon x on the left hand side. I'll write this as So if I'll solve it, I'll get So if I'll factorize it, I'll get this as 2x minus 1, x plus 3, 6 minus 5x and x, and it should be greater than 0. So I'll draw a number line. So I'll get minus 3, and then I'll get 0, 1 by 2, 6 by 5. So this is plus, plus, minus and plus. So it will be minus, plus, minus, plus and minus. Now for this one, I need greater than 0, which is plus. So I'll get either the value of x should lie between minus 3 and 0, or it should lie between 1 by 2 and 6 by 5. Now this result, it has come with the condition, and the condition is x should lie between 0 and 1. So that means this result is only valid when this condition is true. So I need to take the intersection of these two conditions. So I need to take the intersection of these two conditions. So now the interval which is common to both is x belongs to 1 by 2 to 1. Now for the second part, when x is greater than 1, so again I'll write log x, 4x plus 5, 6 minus 5x is less than minus 1. Now this time, because the base is greater than 1, so if I take anti-log, sign will remain the same. So I'll write 4x plus 5, 6 minus 5x is less than x to the power minus 1. So that's exactly the same question but with a different sign. Here the sign was greater than 0. Now I need less than 0. So in this case the answer will be, so this again is minus 3, 0, 1 by 2, 6 by 5, and this is minus, plus, minus, plus and minus. Now what do I need this time? This time I need minus. So that is now again this result, it has come with the condition x should be greater than 1. So the interval which is common to both is x belongs to 6 by 5 to infinite. Now, because it is or, either the base is less than 1 or the base is greater than 1, I need to take the union of these two conditions. So the union of these two conditions is union of case 1 and case 2 will be x belongs to 1 by 2 to 1 union 6 by 5 to infinite. Now I need to take the intersection of this result with the condition of domain. So if I'll take intersection of these two, I'll get, so the first one is minus 5 by 4 to 6 by 5. And the second one is between 1 by 2 and 1. And then from 6 by 5 to infinite. So the interval which is common to both is x belongs to, so from 1 by 2 to 1. So answer to this logarithmic inequality is the value of x should lie between 1 by 2 and 1. I'll take another question. The question is log x square plus x plus 1 to the base mod x is greater than or equal to 0. Now again the first condition will be condition of its domain. So this is x square plus x plus 1. It should be greater than 0. Now it's a quadratic expression and the d value for this one is minus 3. So d is less than 0 and a is greater than 0. So that means this is positive for all x belongs to R. Now next I'll come to condition of base. Now there will be two conditions. Case 1, when mod x lies between 0 and 1, and case 2, when mod x is greater than 1. Now mod x greater than 0, so mod of a number is always positive, but then from here the condition I'll get is x should not be 0 and mod x less than a, so which will give me the value of x should lie between minus a and plus a. So the condition here is the value of x should lie between minus 1 and 0 and 0 and 1. So the condition is minus 1 and 0 or 0 and 1. Now when we have this condition, I can write this as log x square plus x plus 1 is greater than or equal to 0. Now when the base lies between 0 and 1, if I take antilog, sign reverses. So I'll get x square plus x plus 1 and it should be less than or equal to 1. So mod x to less than or equal to mod of x to the power 0, which is 1. So 1 and 1 will cancel. I'll get x square plus x is less than or equal to 0. So this is x plus 1 less than or equal to 0. So the result will be minus 1 and 0. So this is plus, minus and plus. I need minus. Now this result, it has come with the condition and the condition is mod x should lie between 0 and 1. So which is either x lies between minus 1 and 0 or x lies between 0 and 1. So the interval which is common to both is x belongs to minus 1 to 0 or when the base is greater than 1, so when mod x is greater than a, then x is less than minus a or x is greater than plus a. So in that case, what I'll get is log mod x square plus x plus 1 should be greater than 0. Now here, because the base is greater than 1, if I take antilog, sign will not change. So again, I'll get the same result. Now here, this, so previously we need minus, now here we need plus. Now again, this result, it has come with a condition. Either the value of x is less than minus 1 or the value of x is greater than 1. So the interval which is common to both is x belongs to minus infinite to minus 1 union 1 to infinite. Now because it is an OR sign, I need to take the intersection of these two conditions. So the intersection is x belongs to from minus infinite to minus 1, then followed by minus 1 to 0, union 1 to infinite. Now I need to take the intersection of the result which we have gotten in step 2 and the condition of domain. Now because domain is 2 for x belongs to R, so answer to this question will be, so their intersection will be the same result. So answer to this question is x belongs to, so minus infinite to minus 1, union minus 1 to 0, union 1 to infinite. So this is how we solve logarithmic question when the base of log is a variable quantity. Now again for this question, I'll need to solve the inequality. So what I'll do is I'll write it as log x to the base 5. And now this is log m by n, which is log m minus log n. So I can write log x to the base x minus log 3 to the base x. And this is log x base 5 and minus 2 log x base 3. And this is log x base 3. Now log x base x is 1. Now what I'll do is I'll let log x base 5 as a and I'll let log x base 3 as b. So I'll write it as this is a plus 1 and then minus. Now log 3 base x is 1 upon log x base 3. So this is 1 upon b and this is a 2 minus b upon b. So I'll take everything on the left hand side. So I'll write ab plus b minus 1 upon b and minus a 2 minus b upon b, and it should be greater than 0. So I'll write it as twice ab minus 2a plus b minus 1 upon b, and it should be greater than 0. So if I'll take 2a common, so I can factorize it as 2a plus 1 b minus 1 and b, and it should be greater than 0. So again, if I'll put the value of a and b, I can write it as 2 times log x to the base 5 plus 1, and this is log x to the base 3 minus 1 upon log x to the base 3, and it should be greater than 0. Now if we look at the domain also, so domain in this case will be x should be greater than 0 and x should not be equal to 1. So now I'll find critical points. So from this one I'll get log x base 5 equals minus 1 by 2. X is 5 to the power minus 1 by 2, so which is 1 upon under root 5. Now from this log x base 3 is equal to 1, so I'll get x as 3, and from the denominator I'll write log x base 3 is equal to 0, I'll get x is equal to 1. So there are 3 critical points, so which is 1 by under root 5, 1, and then 3. Now the sign of the rightmost is plus, so this is plus, minus, plus and minus. I'll need plus, so which is x should lie between 1 upon root 5 to 1, or x is greater than 3. So x belongs to 1 upon under root 5 to 1 union 3 to infinite. So that is the answer to this inequality. Now the question is solve the inequality log x square minus 10x plus 22 to the base log x by 2 to the base 2. Now first thing, I'll find domain of this function. So this x should be greater than 0. So x square minus 10x plus 22, it should be greater than 0. So if I'll find the roots will be x equals 10 plus minus so it will be 5 and plus and minus root 3. So which is 5 minus root 3, and this is 5 plus root 3. So this is plus, minus and plus. I need what? Greater than 0. So either it is less than 5 minus root 3 or it is greater than 5 plus root 3. Now because the base is variable, we'll take two separate cases. Case 1, when base lies between 0 and 1. And case 2, when the base is greater than 1. Now if I'll take antilog, I'll write it as, so 2 to the power 0 is less than x by 2 is less than 2. I'll multiply it by 2, so this is 2 and x and 4. So because the base lies between 0 and 1, it will be a decreasing function. So if I'll take antilog, sign of the inequality will reverse. So I'll take antilog and I'll write x square minus 10x plus 22, and sign will reverse and will be log 1 by 2x to the power 0, which is 1. So I'll write it as x square minus 10x plus 21, and it should be less than 0. So if I'll factorize, I'll get this as 3 and then 7. So it is plus, minus and plus. I'll need less than 0. It should lie between 3 and 7. Now this result, it has come with the condition that x should lie between 2 and 4. So the interval which is common to both the conditions is x belongs to 3 to 4. Now for the second case, when base is greater than 1, I'll get this result as x by 2 is greater than 2. That is, when x is greater than 4. And in that case, I'll get the same result but with opposite sign. So x square minus 10x plus 21 should be greater than 0. So in that case, again I'll get the same result, 3 and 7. So it'll be plus, minus and plus. So now I'll need plus. So x should be less than 3 or greater than 7. And this result, it has again come with the condition that x should be greater than 4. So from the second case, answer is x belongs to 7 to infinite. Now, either the base lies between 0 and 1 or base is greater than 1. So there is an or. So I'll need to take union of these two conditions. So if I'll take union, I'll get x belongs to from 3 to 4 union 7 to infinite. So finally, I'll need to take intersection of this result and the condition for domain. So if I'll take intersection, the result I'll get is, so first one is either it'll lie between 3 and 4, or it will be greater than 7 from this, or it should be less than 5 minus root 3. Now 5 minus root 3 will be 3 point something. Greater than 5 plus root 3. 5 plus root 3 is 6 point something. So the interval which is common to both the conditions is x belongs to, so from 3 to 5 minus root 3 union 7 to infinite. So the answer to this inequality is either the value of x should lie between 3 and 5 minus root 3, or it should be greater than 7. Now the question is, solve the inequality log x to the base 1 by 2 plus log x to the base 3 is greater than 1. So the problem here is we have a different base. So here the base is 1 by 2. So what I'll do is I'll change the base of inequality to 2. So I can write it as minus log x base 2, and I'll write this as log x base 2 upon log 3 base 2, and it should be greater than 1. So now I can take log x base 2 common. So if I'll take log x base 2 common, I'll get minus 1 plus 1 upon log 3 base 2, and it should be greater than 1. So which is log x base 2 1 minus log 3 base 2 upon log 3 base 2 is greater than 1. So now I'll take it on the right hand side. Now 1 minus log 3 base 2 is a negative number. So when I'll multiply with a negative number, sign of the inequality will reverse. So I'll write it as log x base 2 should be less than log 3 base 2 upon 1 minus log 3 base 2. Now I'll take antilog. So I'll get this result as x equals 2 to the power log 3 base 2 upon 1 minus log 3 base 2. Now domain of this function is x should be greater than 0. So answer to this inequality will be the value of x should lie between 0 and 2 to the power log 3 base 2 upon 1 minus log 3 base 2. Now the question is solve the inequality under root of log 9x minus 3 to the base 3 is less than equal to log x minus 1 by 3 to the base 3. So what I'll do is I'll write it as under root of log, and I'll write 3 into 3x minus 1, and here also I can write it as log 3x minus 1 by 3. So now I can use the property of log m into n, which is log m plus log n, and log m by n. So I'll write this as under root of 1 plus log 3x minus 1 is less than log 3x minus 1 and then minus 1. Now before solving this question, we need to discuss domain of this function also. So in order to find domain, so what I'll do is I'll write log 9x minus 3, and this value should be greater than or equal to 0. So if I'll take antilog, I'll write 9x minus 3 is greater than or equal to 1. So x is greater than or equal to 4 by 9. So that is the restriction of its domain. Now we'll take two separate cases. Now case 1, when this right hand side is less than 0, so this, which is log 3x minus 1 is less than 0, that is log 3x minus 1 is less than 1. If I'll take antilog, I'll get 3x minus 1 is less than 3, that is when x is less than 4 by 3. Now when x is less than 4 by 3, left hand side it is a positive square root, so it will be positive, and right hand side is negative. Now positive number cannot be less than a negative number. In this case, I'll get no solution. Now for the second case, when log 3x minus 1 is greater than or equal to 0, that is, if I'll solve in the same way, I'll get this result as x is greater than or equal to 4 by 3. Now when x is greater than or equal to 4 by 3, now both left hand side and right hand side, they are positive. So I'll write it as 1 plus log 3x minus 1 is less than log 3x minus 1 and then minus 1. Now I can square it and solve it. So what I'll do is I'll let log 3x minus 1 is y. So I'll write under root of 1 plus y is less than y minus 1. So if I'll square it, I'll get 1 plus y is less than y square plus 1 minus 2y, which is y square minus 3y is greater than or equal to 0. So I can write it as y minus 3 is greater than or equal to 0. So which is 0 and 3. So it is plus, minus and plus. So what I'll get is either y is less than or equal to 0 or y is greater than or equal to 3. So now I'll put the value of y. So if I'll put the value of y, I'll get this as log 3x minus 1 to the base 3 should be less than or equal to 0, or log 3x minus 1 to the base 3 should be greater than or equal to 3. So if I'll take antilog, I'll get this result as 3x minus 1 is less than or equal to 3 to the power 0, which is 1. That is, x is less than or equal to 2 by 3, or if I'll take antilog here, I'll get 3x minus 1 is greater than or equal to 3 cube, which is x is greater than or equal to 28 by 3. Now this result, it has come with the condition, and the condition is x should be greater than or equal to 4 by 3. So that is the only condition from this case I'll get is x should be greater than or equal to 28 by 3. Considering its domain also, the only result in this case possible is x should be greater than or equal to 28/3. Now for the second question, I'll take antilog. So I'll write now x square plus mod of x minus 5 is always positive, so I can cross multiply. I'll write x square minus 4x plus 3, and this is greater than x square plus mod of x minus 5. Now again I see two modulus functions. So for this one, x square minus 4x roots are 0 and 4. So this is plus, minus and plus. And for this one, definition changes at 5, plus and minus. So I need to take three separate cases. Case 1, when x is less than 0, or x lies between 4 and 5. Case 2, when x lies between 0 and 4. And case 3, when x is greater than or equal to 5. Now, when x is less than 0, or when x lies between 4 and 5, this expression is positive. So I can write x square minus 4x plus 3 is greater than or equal to x square. Now, what about x minus 5? It will be negative. So minus x minus 5. So I'll cancel x. So I'll cancel x square. I can write 3x is less than minus 2. I'll get x is less than or equal to minus 2/3. Now x is less than minus 2/3. It lies in this interval. So that's my first solution. Now when x lies between 0 and 4, first expression is negative. So I'll get minus x square minus 4x plus 3, and this is greater than x square, and here again it will be negative. So minus x minus 5. So I'll get minus x square plus 4x plus 3 is greater than x square minus x plus 5. So if I'll take it on the right hand side, I'll get 2x square minus 5x, and then plus 2, it should be less than 0. So I'll get 2x minus 1, x minus 2 should be less than or equal to 0. So this is 1/2, and then 2 plus minus and plus. I need what? I need minus less than or equal to 0. So which again lies in the given interval. So from the second case, the answer I'll get is x belongs to 1/2 and 2. Now when x is greater than 5, so in that case, both the expressions, they are positive. So I can write it as x square minus 4x plus 3, and this is greater than x square plus x minus 5. So I'll cancel this one. So if I'll solve it, I'll get x is less than or equal to 8/. Now this solution, it doesn't lie in this interval, so I'll discard it. So answer to this question will be either x is less than or equal to minus 2/3, or x lies between 1/2 and 2.